Hello and welcome to our physics class. Today we are going to study about interference of light. To understand this interference of light, you'll have to know about superposition principle of waves. According to this principle, at a particular point in a medium, the resultant displacement of a wave will be equal to the algebraic sum, or we call it as the vector sum of all the individual displacements. I'll write down here, according to this principle, at a particular point in a medium, the resultant displacement, let us take it as y, the resultant displacement is equal to the algebraic sum, or we can call it as the vector sum of all the individual displacements. So it says like this: if y is the resultant displacement, then it will be y1 plus y2 plus, the individual displacements are suppose y1, y2 and so on. Then it will be y1 plus y2 plus y3 and so on. So this is a vector sum. Sometimes it may be plus, sometimes it may be minus. If I write a vector sum, then I'll write like this with one arrowhead on the top. Now this principle I will show you diagrammatically. Suppose this is your time axis and this is your displacement. Y axis is your displacement. And x-axis is your time axis. Suppose this is one wave. Its maximum amplitude is here, suppose say y1. Another wave, this is the second wave. Its displacement is say suppose y2. Then the principle says that the sum total of y1 and y2, it will be bigger, y1 plus y2 is, y1 is 1 centimeter, y2 is 2 centimeter, and 1 plus 2 will become 3 centimeter. So that will give us the resultant. This will be your y. Your y is equal to y1 plus y2. This is your resultant wave. Its amplitude will be more than y1 and y2. It will look like this. Now another diagram, if I draw and show you the superposition principle. Suppose again the same thing, this is time axis, this is your displacement, This is the origin. One wave, say like this, is traveling, and then the other wave, it is coming this way, like this. In this case, the two waves here, the two waves, the black and the blue. This is your black one is the first wave. This is your second wave. Here also, this is your first wave. This is your second wave. In this case, you can see that the first wave and the second wave, they are in the same phase. Both of them are in the same phase. So here, when you do the vector sum, here it will be plus. First, if you do the vector sum, it will look like this. Ultimately, when you remove the vector, it will still remain y1 plus y2. But in this case, the first wave and the second wave, they are in opposite phase. The crest of the first wave and the crest of the second wave, they are opposite to each other. In that case, the resultant wave, here suppose this is y2. The displacement is y2. And the second, in the first wave, the displacement is suppose y1. Now in this case, when you use superposition principle, then the resultant wave y is equal to, according to superposition principle, y1 plus y2. In vectorial way, if I write, if I remove the vector sign, y will become, y1 is bigger than y2, so it will be y1 minus y2. y1 minus y2. y2 will become negative. It is in the opposite phase. In this case, the resultant will be y1 minus y2. Suppose if it is 3 centimeter, this is 1 centimeter. 3 minus 1 will be 2. So it will come here. The resultant value of y will come here. It will be smaller than y1. It will be larger than y2. So this will give you your resultant wave. The red one is your resultant wave. So this is your superposition principle. You can refer to these two diagrams. It will become clear to you. Still, one more thing you have to know, that is coherent sources of light. When we say coherent sources of light, these are the sources of light which have same frequency, or coherent sources of waves also we can say, those waves which have the same frequency, same wavelength and same phase, or a constant difference of phase between the two waves. Then those sources of waves, we call it as coherent sources of waves or coherent sources of light. Same two sources of light having same wavelength, same frequency, and same phase. Or we say the same phase difference or constant difference of phase between them. Constant difference of phase are known as coherent sources of waves, or we are talking about light now, sources of light we'll say. So two waves, two sources having the same wavelength, same frequency and same phase, or constant difference of phase between them, are known as coherent sources of light. So this is a condition you need to know to study interference of light. If the sources are coherent, then only we can observe this interference pattern or interference of light we can study. Now let us see about interference of light. Interference is the phenomena of superposition of two light waves, two coherent sources of light waves to produce maximum intensity at some point and minimum intensity at some other point. The points where you'll get maximum intensity is known as constructive interference. You'll get at some point, and so at some other points you'll get minimum intensity. Minimum intensity means destructive interference. So two types you'll get. Sometimes it will be constructive, sometimes it will be destructive. But you must be sure that they are the two light waves which you are making them to interfere or superimpose each other must be coherent sources. Now let us try to understand this diagrammatically. Diagrammatically, if I draw one constructive interference, this is your displacement, we represent with y. Suppose this is your first wave, and then this blue line that you can see, it is your second wave. When crest of one wave coincides with the crest of the other wave, or throw of one wave coincides with the throw of the other wave, then you get constructive interference. The resultant intensity will become more. This is your constructive interference. This is the resultant. As I have said earlier, and same type of diagram that I have drawn earlier also. Here this is y1, suppose this is y2. As they are in the same phase, that means crest, they throw they are overlapping each other, then you get an intensity higher than the other two. Sum of these two, y1 plus y2, will be given by y. Here will be y1 plus y2. That is your constructive interference. Here the intensity will be maximum, brightness will be more. Suppose if you take these are light waves. Now the second one, that is our destructive interference. If you look, this is your displacement axis, this is your time axis, this is your origin. In destructive interference, suppose this is one wave, the first wave. And then the next wave is also of the same displacement. This is your second wave. Here, if it is y2 and this is y1, it will give us zero resultant. The displacement will become 0. Why? Because if y1 is 2 centimeter, y2 is also 2 centimeter, 2 minus 2 will become 0. In that case, the resultant intensity you cannot see. Here y equal to y1 plus y2. Vectorially if you write, but if y1, y2 they are in opposite phase, so if I write here minus, then it will become 0 and you will get destructive interference. Here you cannot see the resultant intensity, or if you see also you cannot see at all. It will become dark. This minimum intensity will become dark. The resultant wave we cannot see at all. Cannot even draw like this also. Completely it will become 0. So this is the two difference. That's why to study interference, the sources must be coherent. That means the amplitudes must be almost the same. Then you get destructive. And here also, if I increase this amplitude, if I make the displacement y1 here itself coinciding, then also the resultant will become maximum. That will give you constructive interference. Now let us see about the theory of interference. Theory of interference of light or light waves. Let, like this will take, let light from two different sources be represented by let us take the first wave as displacement as y1 is equal to a sine omega t. This is the equation of wave, all of you know. Here the phase angle is 0. And the second wave, let us take it as y2. Let the amplitude be b sine omega t plus phi. This is the phase angle. Now the second wave is advance of the first wave by the phase angle phi. Second wave is leading the first wave. Now here y1 and y2 are displacements of two waves, and A and B are the amplitude. A and B are the amplitudes of the waves, and phi is the phase angle by which the second wave leads the first wave, by which the second wave leads the first wave. Then if we apply here the superposition principle, applying the superposition principle, the resultant amplitude displacement y, we'll write it as y1 plus y2. Y1, as you know, it is a sine omega t, plus y2, it is b sine omega t plus phi. This one you can write it as b sine a plus b. Your compound angle formula you can use sine a cos b plus cos a sine b. This is your formula. Sine a plus b is sine a cos b plus cos a sine b. Now opening the bracket, b sine omega t into cos phi plus this is b cos omega t sine phi. Then your resultant displacement y will become sine omega t, if you take common, it will be a plus b cos phi sine omega t plus b sine phi cos omega t. Like this you will get it. This one will mark it as equation number 3. Now putting this bracket term a plus b cos phi is equal to a cos theta. You may be thinking that why we are putting a plus b cos phi as a cos theta. Here a represents the amplitude of the resultant wave, resultant displacement of the wave, and theta is the phase angle for the new wave that will form. Because we are adding this to y1 plus y2, then we get a new wave. So what will be the new wave equation? We are trying to get it. This one will mark it as equation number 4, and this b sine phi is equal to, substitute as a, amplitude must remain the same for the resultant wave, sign also must not change, but the phase angle changes. So we mark it as theta, the phase angle. Let us mark this as equation number 5. Now if you put the value of 4 and 5 in equation 3, you'll get y is equal to a cos theta sin omega t plus b sin phi, this a sin theta cos omega t. Like this will appear. Then you will get this as a is common, sin omega t cos theta plus cos omega t sin theta is sin omega t plus theta. So this will be your new wave equation, or we can call it as displacement of the resultant wave. This one marked as equation number 6. Here you can see A is the amplitude of the resultant wave. Here A is the amplitude of the resultant wave, and theta is the phase angle of the wave. Now, if this is the resultant wave and theta is the phase angle, then diagrammatically if you represent, it will appear like this. For amplitude A, there was no phase angle. Y1 is equal to small letter a sin omega t, plus nothing was there, 0. So with amplitude A it looks like this. Then with phase angle phi, you got the amplitude B. This is the second wave. This is for the second wave. And for the resultant wave, the amplitude is A and the phase angle is theta. So it will come here, the resultant wave with amplitude A, and this is the phase angle theta. Like this we can represent. Now let us see the expressions. What is the value of the resultant amplitude? To know this and to know this phase angle theta, we'll have to proceed like this from equation 4 and 5, squaring and adding equation 4 and 5. Squaring and adding equation 4 and equation 5. If you square it, a square cos square theta plus a square sin square theta. Alright, this is a square sin square theta plus a square cos square theta is equal to, here you will get a plus b cos phi, a plus b cos phi, the whole square, plus b sin phi. You can write directly b square sin square phi. Now here a square, if you take common, you will get sin square theta plus cos square theta. Here you will get a square plus b square cos square theta, that is a square plus b square I have done, plus 2ab. 2a is a, b is b cos phi, b cos phi, plus this is b square sin square phi. Don't get mixed up with the diagram. Diagram is this way. Now a square, this is using identity to be 1. A square is equal to a square, then this one b square you can take common, a square plus b square if you take common, cos square phi plus sin square phi you will get from this term and this term, plus 2ab cos phi, plus 2ab cos phi. So this will become a square plus, this is again 1, sin square theta plus cos square theta is 1, b square plus 2ab cos phi. So ultimately a, if you remove the square, it will become square root of a square plus b square plus 2ab cos phi. This will give you the amplitude of the resultant wave. Let us mark this is equation number 7. If I have not mistaken, 6, then this is 7. Now, to get the value of theta, we have to divide equations 4 and 5. Now your equation 4 and 5, if you divide it, you will get, first it was fifth equation, it is a sin theta. So I will write a sin theta divided by right hand side of equation 5, it was a cos theta. A cos theta is equal to, first sine term, left hand side of equation 4 it was b sin phi, and left hand side of equation 5 it was a plus b cos phi. Now sin theta by cos theta, a you can cancel it, sin theta by cos theta is tan theta is equal to b sin phi divided by a plus b cos phi. So theta you can calculate from here, it will be tan inverse of b sin phi divided by a plus b cos phi. Let us mark this as equation number. This is the phase angle of the resultant wave. Mark it as equation number 8. Now for quite some time, when we are doing squaring and adding, when we are dividing equation 4 and 5, we are doing for the resultant wave. What is the angle theta, the phase angle, and what is the value of the amplitude to find out we have done. Now again to continue, you will start like this. Since intensity of a wave is directly proportional to the square of their amplitudes, for the first wave we write directly proportional to the amplitude. The intensity I is directly proportional to the amplitude square. This one you have to know the formula. Then for the first wave, if I write I1, intensity of the first wave, I'll mention it here. Intensity of first wave, if I write it as I1, then it will be equal to the proportional sign. If we remove, we take one constant k here, and the amplitude of the first wave is a, so it will be k a square. Like that, intensity of the second wave, that is before interfering, I2 is equal to, amplitude is b in second wave, constant term is k, so it will be k b square, and resultant intensity, that is for the resultant wave, resultant intensity, if I take, then I'll write IR is equal to k, amplitude is a square. Now what is the value of a square that you already know? Just now you have I have rubbed it, but you know the value. So what you will do is, you will put it here, k a square plus b square plus 2ab cos phi. This is the amplitude of the resultant wave. It is along with square root if it is writing. This will give you the intensity of the resultant wave. Now let us see for constructive interference. For constructive interference, now the resultant intensity must be maximum. For which value cos phi is maximum, then you know that it is for 1. Maximum value of cos phi is 1. For maximum intensity, cos phi, that is maximum, will be equal to plus 1. Then the principal values of phi, therefore phi will take the values 0, cos 0 degree is equal to 1, cos 2 pi is equal to 1, cos 4 pi is equal to 1. Like this you will find out the values of phi. And this gives us the phase difference. This is your phase difference phi. Now after getting your phase difference, your class 11 concept will be using relation between path difference and phase difference. If I take delta x is the path difference of the two waves, then path difference delta x is equal to lambda by 2 pi the phase difference, that is phi. Now if the phase difference phi is equal to 0, 2 pi, 4 pi, then the general term you can use it as 2 n pi, where n can take values 0, 0 into everything will become 0, 1 if you take 1 into 2 is 2 pi, 2 if I take 2 to 4 pi, it should match with this, where n starts from 0 here, 1, 2, 3 and so on. Then this phase difference, if you put it here, delta x, or path difference will be lambda by 2 pi, and phi, your phase difference is 2 and pi. Here pi you can cancel it. Then you will get 2 also, you can cancel it, you will get n lambda. So for constructive interference, the path difference should be equal to n times lambda. N times lambda, n can be 0, 1, 2, 3 and so on. For maximum intensity, if you put it in your formula, maximum intensity formula, it was I maxima, it is equal to K amplitude square, it is A square plus B square plus 2AB cos phi. This is K A square plus B square. Suppose if it is maximum intensity, then I write the resultant intensity you wrote earlier, this is the resultant intensity. Then if I make it as I maxima, then cos phi value is 1, so it will become A plus B the whole square. Like this will appear when you put the value of cos phi maximum, that is 1. Cos phi maximum is plus 1, and maximum intensity I maxima is directly proportional to, if you don't write K, directly proportional to A plus B the whole square. This will give you the maximum intensity for constructive interference. The same way we'll see for destructive interference. For destructive interference, for minimum intensity, cos phi must be minimum, and that is equal to minimum value of cos is minus 1. So the phase difference phi will take values, odd numbers, 3 pi, 5 pi, 7 pi, and so on, and your principal value will be 2n minus 1 pi. But here n will not start from 0, it will start from 1. If you put 1 here, 2 ones are 2 minus 1 is 1. Then 1 into pi is pi. That means here 1 pi also will come. Then if you put 2, 2 to the 4 minus 1 is 3. 3 pi by, will be 3 pi. If it is 3, 3 to the 6 minus 1 is 5 pi. Like this to match. Then if delta x is the path difference of the two waves, then the relation will remain the same. Here it will change. This is 2 pi. Phi is equal to 2n minus 1 pi. So pi if you cancel it, then you will get the relation in path difference and phase difference. This path difference is equal to lambda by 2 times 2n minus 1. And the minimum intensity will be directly proportional to a minus b whole square. This one cos phi, if it becomes minus into plus will become minus 2ab. Then minus 2ab, then it will become a minus b the whole square. That is for minimum intensity. So with these things to be remembered, this one you will have to remember. Now while doing Young's slit, experiment the relation between path difference and phase difference for destructive interference, and for constructive interference you got like this: delta x equal to n lambda. This is for constructive interference, and this is for destructive interference. Thank you and have a nice day.